Hello guys, welcome to my YouTube channel. So in this video, we are going to learn about the Hexose monophosphate pathway. So this is a pathway you run process that occurs inside the cell, and I'm going to tell you some of the reasons why this process is necessary inside the cell. Now, when glucose gets inside the cell via a receptor, so these receptors for glucose are always called blood receptors. Glucose, which is a 6-carbon molecule, will get into the cell via the blood receptors and may undertake a process called glycolysis. Mostly we know when glucose gets into the cell, it undergoes glycolysis. Now, let's see. For glycolysis, glucose gets inside the cell and is going to be converted to glucose 6-phosphate. To mean it's going to be phosphorylated and you are going to use ATP. This is going to be reduced to ADP. Right? And this is enhanced by an enzyme called hexokinase. It's a kinase going to phosphorylate glucose to form glucose 6-phosphate. But now see it this way. Sometimes inside the cell, the glucose 6-phosphate may not proceed to glycolytic pathway, or may not proceed by glycolysis, and therefore it may be acted upon by another enzyme, and that's what we want to see. It is from glucose 6-phosphate that we are going to derive the hexose monophosphate pathway. Now let's say this. When glucose 6-phosphate is acted upon by an enzyme, and this enzyme is called glucose 6-phosphate dehydrogenase. Glucose 6-phosphate dehydrogenase. And I told you that when you hear the term dehydrogenase, to mean something has happened now. See this one. We're going to convert NADPH to NADP plus to NADPH. And actually, this is one of the reasons, actually the main reasons why we undertake hexose monophosphate pathway. It's just to generate NADPH, which will be taken into other pathways inside the cell. Now, glucose 6-phosphate dehydrogenase acts on glucose 6-phosphate and form this molecule here. This is called 6-phosphogluconolactone. 6-phosphogluconolactone. It's very difficult to pronounce. 6-phosphogluconolactone. Now that comes as a result of action of glucose 6-phosphate dehydrogenase on glucose 6-phosphate. Now, from 6-phosphogluconolactone, we are going to have another enzyme coming into play. Now see this. 6-phosphogluconolactone is going to be acted by an enzyme called lactonase. This enzyme is called lactonase. Now, this enzyme called lactonase is going to act on 6-phosphogluconolactone, and there is going to be usage of a water molecule. And we are going to generate a proton there. Now, this lactonase enzyme is going to convert 6-phosphogluconolactone to 6-phosphogluconate. Alright. We have 6-phosphogluconate. Now, let's proceed. 6-phosphogluconate is going to be acted upon by another enzyme. What is this enzyme? See this. This enzyme is called 6-phosphogluconate. 6-phosphogluconate dehydrogenase. And I told you, whenever you get the term dehydrogenase, it comes from NADPH in this case. So NADP, DP plus is going to be converted to NADP. Alright. Yeah, there. Now, this enzyme called 6-phosphogluconate dehydrogenase is going to convert 6-phosphogluconate into ribulose 5-phosphate. It's going to convert 6-phosphogluconate into ribulose 5-phosphate. Now, let's proceed. All these things that we have done from 6-phosphogluconate until ribulose 5-phosphate, this part here is called oxidative part or oxidation part. or part of hexose monophosphate pathway, right? So this part is called oxidative. All these parts from this side here, oxidative. Oxidative. Now we are going to non-oxidative part. Now let's see. Ribulose 5-phosphate can be acted upon by two enzymes. So it depends upon the enzyme that acts on it. Now, when it is acted upon by an epimerase enzyme, so we have ribulose 5-phosphate epimerase. So I'm just going to write epimerase. Epimerase. This ribulose 5-phosphate is going to be converted to xylulose 5-phosphate. But when it is acted upon by an isomerase, ribulose 5-phosphate isomerase, it's going to be sodium-like isomerase. It's going to be converted into ribulose 5-phosphate. Ribulose 5-phosphate. Right. So it just depends upon the enzyme that acts on it. When it's acted upon by an epimerase enzyme, that is ribulose 5-phosphate epimerase, it's going to be converted to xylulose 5-phosphate. But when it is acted upon by ribulose 5-phosphate isomerase, it's going to be converted to ribulose 5-phosphate. Now this is the beginning of non-oxidative part. Now let's proceed. These two products can react. Now let's see what they are going to give us. In the presence of an enzyme, they are going to react. Now, this is in the presence of an enzyme called transcatalase enzyme. Transcatalase. So, what is this enzyme going to do? Now, this enzyme is going to take, so it's called ribulose 5-phosphate. It's going to take 2 carbons from ribulose 5-phosphate and add it to xylulose 5-phosphate. Now, let's see. When it takes 2 carbons from here, this is going to be reduced to glyceride 3-phosphate. Then those 2 carbons are going to be added to this one, xylulose 5-phosphate. So it's going to be converted to, so they're going to be 7. So we have cellular hexose 7-phosphate. So tricky to pronounce. It's called cellular hexose 7-phosphate, right? Now, these two, now of course we know where this can go. This can come here. You know, again glycolysis. That's the connection between hexose monophosphate pathway and glycolysis. You'll see some of the products from this part coming to this one. The same way you can get some to generate hexose monophosphate pathway. Now, products. Now, these two can again react. These two can again react. Now, let's see what they're going to give us. In the presence of an enzyme called transadenylase. Transadenylase enzyme. Right. Now they are going to give us what? This transadenylase enzyme is going to take 3 carbons. Actually, 3 carbons from cellular hexose 7-phosphate. I told you it has 7 carbons. So this transadenylase enzyme is going to take 7 carbons from this one and give it to this one. When it gives it to glyceride 3-phosphate, it's going to be converted to fructose 6-phosphate. But how many carbons does it have now? It has 4. So it's going to be called erythrose 4-phosphate. Right. Now let's proceed. So you know this was to carry inside the cytoplasm. So inside the cytoplasm, actually you know this one can also come to glycolysis. This fructose 6-phosphate, this fructose 6-phosphate. So it can again come to glycolysis and continue the glycolytic pathway. Now, remember inside the cytoplasm we can also have some other molecules of ribulose 5-phosphate. So let me say you have ribulose 5. Let me just write it. Ribulose 5-phosphate. Now, this ribulose 5-phosphate can again be acted upon by an enzyme, this epimerase enzyme, right? Now, it can be acted upon by epimerase. 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 And what did he say? He said that epimerase is going to convert to xylulose 5-phosphate. So you have xylulose 5-phosphate. Xylulose 5-phosphate. Now, xylulose 5-phosphate can again react with erythrose 4-phosphate. Now let's go down to form. This is done in the presence of an enzyme called transcriptolase. Right. This is called transcriptolase. Now this enzyme is going to take 2 carbons from xylulose 5-phosphate and add it to erythrose 4-phosphate. Now let's see what's going to happen. If it takes 2, add to this one, this is going to be reduced to 3. So I'm going to have the right 3-phosphate. Right. Then what do we have this side? We have fructose because then our has added to fructose 6. Fructose 6 phosphate. Alright, so all these steps here from this one here, this constitutes the non-oxidative part. Non-oxidative. Now, these ones, the product such as glyceride phosphate, because you know, you can come and then glycolysis, right? Fructose 6 phosphate, the same thing, can come. Can come, fructose 6 phosphate, the same and this one. So these two processes are interconnected, and the main reason why the body undergoes this process is because when we generate NAD pH molecule, which will be taken to other pathways which are necessary and very crucial so far as cell functioning are concerned. Now, this is all about Hexose monophosphate pathway. If you find this video helpful, please make sure you subscribe to my YouTube channel for more videos. Thank you.